So today we're going to be talking about solving systems by graphing. We're going to basically be looking at two lines and looking at how we graph those two lines to figure out where the problem crosses. Now, on your desk you should have your foldable, so you've already gone ahead and folded that in half, and we'll put that in our notebook here in a second. So this should be number 17, solving systems of equations by graphing. So what I want to do first is I want to look at this first problem that you see over here on the left that says solve by graphing, and then it gives us these two equations you see up here. So that's going to be y is equal to negative 1/3 x plus 3, and y is equal to 2x minus 4. So what we have here is we basically have two lines that are in slope-intercept form. And what we want to do is we want to solve this by graphing. So in order to do so, all we're basically going to do is graph those two lines on our chart down here, on our coordinate plane, and determine where those two lines intersect. So to solve this by graphing, the first thing I'm going to do is I'm going to identify my intercept. In this problem, the first one is going to be positive 3. So what I'm going to do with that is I'm actually going to start at 0, 0, and I'm going to go up 1, 2, 3, and I'm going to put a point right there on positive 3. Now, the next thing I'm going to do is I'm going to take and I'm going to do my slope. So in this problem, to identify my slope, I'm going to pay attention to the number that's in front of the x, which is going to be negative 1/3. So negative 1/3 just simply means that I'm going to go down 1, and I'm going to go to the right 1, 2, 3. And I want to put a point. Now I'll continue that pattern, okay? I still want to go down 1, and to the right 1, 2, 3. I can also go up 1, and to the left 3, 1, 2, 3. And I can also continue that pattern all the way until I get all the way across the problem. Now the key here is to make sure that when I'm graphing these, I graph them across the entire coordinate plane. So once I have my information down, these are different from equality or inequalities. They actually have an equal sign, so we know it's going to be a solid line. So all we need to do here is we're just going to take and we're going to draw our line all the way across. Now when we draw that line, we want to make sure we do it as straight as possible. I kind of got a little bit off here. But we want to make sure we do it as straight as possible. So it may not even be a bad idea to use a ruler today when you're doing these. Now the second thing we're going to do is we're going to graph the line 2x minus 4. Now 2x minus 4 is graphed the exact same way. We first start off with our y-intercept here, which is negative 4. And we're going to go down 1, 2, 3, 4, and we're going to put a dot. Then 2x is going to be basically 2 over 1, so that's going to be our slope here. So 2 over 1 means that we're going to go up 2 and to the right 1, 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 up 2 and to the right 1. We could also go down 2 and to the right or left 1. Once we have that information, we're then going to take and graph our line all the way across. And what we've done is we've graphed the system of equality or system of equations here. So now that we've got our system of equations graphed, all we're going to do is we're going to look for where those two lines intersect. So when we look at these two lines and where they intersect, if we look at that point that they cross, which is going to be located right here, that's going to be at the point 1, 2, 3, 1, 2. So that's going to be at the point 3, 2. So here, the correct answer for this problem would be 3, 2. Now, what I want you to do is I want you to take a second and go ahead and see if you can solve the second one here that says solve by graphing. Y is equal to negative 4/3 x plus 5, and y is equal to negative 4/3 x. So go ahead and take a second and see if you can solve that problem now. Oh well. Yes. Alright, so coming back to this second problem we have up here on the board, it says solve by graphing, and it gives us y equals negative 4/3 x plus 5 and y equals negative 4/3 x. So when we graph this one, we should notice that we have the same slopes here because both of these numbers are going to have the same slope. We do have different y-intercepts though, and the thing is with this one, you can actually go on to the end of it since this has an x and a y in it and add a +0 to the end if it helps you work this problem. So what we're going to do here is we're going to work both of these out and see what we come up with, and then discuss the solution that we get. So on this one it says solve by graphing. So we want to do y equals negative 4/3 x plus 5. So that means that we have a y-intercept of plus 5. So we're going to go up 1, 2, 3, 4, 5, and we're going to put a point at 5. And then from there we're going to go down 4 and to the right 3. So we're going to go down 1, 2, 3, 4, and then to the right 3. So that's going to be 1, 2, 3, and we're going to put a dot there at 3. We can continue this pattern by going down 4 and to the right 3. So down 1, 2, 3, 4, and then we can go to the right 1, 2, 3. Now, once we get to that point, what we can do then is we can go ahead and connect our points, draw our line, and then graph our second. So to graph our second line, we're going to take and we're going to go start at plus 0, since this is the y-intercept. So that's going to be starting at plus 0. So we're going to put our point 0. And then we're going to go down 4, 1, 2, 3, 4, and then to the right 3, 1, 2, 3. Now, if we could continue that pattern, we would, but it looks like we won't be able to. So what we'll do is we'll go up 4, and then to the right or left 3, 1, 2, 3. And then we can go ahead and graph that line as well. So when we graph that line, we see that we have two lines that are what? Parallel. So anytime we have parallel lines, that means that they're never going to intersect. So in this case, if they never intersect, can we have solutions? No. So this is what we call no solutions. Does anybody have any questions about that? All right, take a second and go ahead and see if you can solve the last one over there on the right. See if you can solve the one that says y equals 3x minus 1 and y equals 3x minus 1. All right, so the last problem we're going to look at here, it says solve by graphing. So to solve by graphing here, all we're going to do, same concept we've been doing. We're going to graph both of these lines. So we're going to graph the y-intercepts. Now, when we graph those y-intercepts, this one says it's going to be negative 1. So to graph negative 1, we're going to start at 0, 0, and we're going to go down 1, and we're going to put a point. Then the slope, it says, is going to be 3. Now understand that's 3 over positive 1, which means we're going to go up 3 and to the right 1. So we're going to start at 1, or negative 1, and we're going to go up 1, 2, 3, and then to the right 1. Up 3, and to the right 1. We could also go down 3, and to the left 1. Now, once we get those points, we can go ahead and graph the line. Remember, we want to make it as straight as possible, and we want to go all the way across the graph. So we take and graph that. Now, the second one we're going to graph here is going to be 3x minus 1. You probably already noticed that these two are what? The same. All right, so these two are actually the same. So if we take and go down 1, we get that point, and then we go 3 over positive 1, right? So that's 3 over 1. So that's going to be up 3 and to the right 1, up 3 and to the right 1, down 3 and to the left 1. So we notice that all those points are going to be on that exact same line. Therefore, it's going to have the exact same solution. So in this case, if we look at our answer choice, we know that these are all going to be the exact same since the lines are the same. So if it's all the same and it's just one solid line, this is going to be what we call all real numbers. Okay, you'll see that answer as an answer choice, or you'll see infinite solutions. So really, either one of those answer choices would be a possibility on the test. Sometimes they'll label it if it's like an older test, or if it's a test that was written by somebody that may have been written a while back. Sometimes it's usually called all real numbers, but then sometimes more recent tests will call it infinite solutions or infinitely many solutions. So you can have a couple different options there. Just know that both of these basically mean the exact same thing. In other words, we can have more than one solution here. We can have infinite solutions. Okay? So really 3 different types of graphs that you're going to see. You're going to see graphs that have one solution, which is the one you see here. You'll have graphs that are going to be no solution, which are parallel, and then you're going to have graphs that are all real numbers or infinite solutions when it's the exact same line. Let's look at one. Let's look at these examples a little bit closer. All right. So, like I said, with this one, we were looking at it. All we basically wanted to do was make sure we graphed both the lines. So what we did was we started with the blue line. We graphed it. We said that we could go up 3. So once we went up 3, we knew that we could go down 1 and to the right 3. So to go down 1 to the right 3 gave us our point. We could continue that pattern if we needed to, but you can basically graph your line at that point. Now the second line it said was 2x minus 4. So that starts by going down 4, and then we're going to go up 2 and to the right 1. So when we go up 2 and to the right 1, it gives us our point. We can continue that pattern, or we can go ahead and draw our line if we have a straight edge. So here we're going to go up 2 and 1, so we can continue that pattern. And we see that it crosses the point there. So we see that our point is going to cross through at 3, 2. So we can identify our solution as 3, 2 with this example. The second example, the middle example that we had, we said that they were going to be parallel lines because they had the same slope but different y-intercepts. So same concept with this one. We plot positive 5. Here we're going to go down 4 and we're going to go to the right 3. So down 4 and to the right 3 will give us our point. And then we can draw our line to get our answer for that line. The next one says that we have negative 4/3 x, so we start at 0 and we plot our point. Then we're going to go down 4 and we're going to go to the right 3. So when we go down 4 and to the right 3, we can plot our point and see that the lines are going to be parallel. Therefore, our answer choice here would be no solution. And then the last example that we said that we had 3x minus 1, 3x minus 1, which are the same lines. So here we went down 1 and put a point. And then we said that we could go up 3 into the right 1. And that gave us a point. We can graph our line. Next, we're going to have the line y equals 3x minus 1. So we plot negative 1. We go up 3 into the right 1. Plot the point. Draw the line. And we notice that it's the same line. So anytime that it's the same line, we know that's what we call infinite solutions, or all real numbers. All right, so that's going to conclude your notes for the day. Don't worry about this page. I put that on there just in case you need extra graphs. If you need extra graphs, feel free to use those. And we'll go ahead and begin the assignment. If you have any questions, feel free to let me know.